Every year, millions suffer from vision loss due to glaucoma, an irreversible condition that often goes undetected until it's too late. But what if we could predict it early using data and AI? In this video, I will walk you through my Capstone project, predicting glaucoma progression using longitudinal patient data and deep learning. So here is the full code for the project in Python programming language, where various libraries have been imported like NumPy, Pandas, Matplotlib, Scikit-learn, TensorFlow, and Keras. And each of these libraries have a specific purpose of its own in this code. For instance, like NumPy and Pandas are used for data manipulation, Matplotlib for data visualization, Scikit-learn is for pre-processing, train test split and matrix, and TensorFlow and Keras are being used in this code as deep learning models. So the code starts with creating and loading the dataset. Here, a dataset is manually created with patient features like patient ID, age, gender, intraocular pressure, cup-to-disk ratio, visual field loss, family history, and glaucoma diagnosis. And here, all the info of 20 glaucoma patients have been written down, have been added manually in this code. After this, we will save this data frame to a CSV file and later on load the dataset. From the same file, we save the data frame in. After this, we separate features X and labels Y. And what's the meaning of features and labels? Features here means input variables, and target label or label means whether glaucoma is diagnosed or not. Then we try to pre-process with column transformer. Here, two variables have been used, one being numeric underscore features and another being characteristic underscore I mean categorical underscore features. Numerical features are standardized with standard scalar, whereas categorical features are one hot encoded using one hot encoder. And these two variables are combined in a column transformer to preprocess both types simultaneously. After this, we transform data and split it. The entire dataset is transformed, that is scaled and encoded, and data is split into 80% training and 20% testing. Then we build neural network model using a sequential Keras model with two hidden, two hidden layers, ReLU activation and dropper for regularization, and one output neuron, which is used for sigmoid for binary classification. And finally, we compile and train the model using atom optimizer and binary cross entropy loss. And through this part, we try to train the model for 20 posts with validation on test data. And here in this code, in this portion, we plot all the values here, like training and validation accuracy values, training and validation loss values, distribution glaucoma diagnosis, and gender distribution, etc. And after all this, we predict the outcome, and all the predictions are converted to binary. And accuracy and classification report like precision, recall, F1 score are printed. So as you can see the output here, all the portions have been executed successfully. There is no error at all. And so here are the graphs, pie charts, and histographs. All are providing correct values here. And here is the precision recall response code support. You can see over here. A macro average and weighted average of the data have been given clearly. So in summary, we simulate a glaucoma patient data set. We pre-process mixed feature types. We build and train a neural network. We evaluate model accuracy, and we visualize both data and model training. However, there's one challenge behind it, and the challenge here is the limited dataset size. Real world medical data is often incomplete and imbalanced. In the future, this model could be improved with more patients, time series data, and clinical validation. So, thanks for watching. If you found this useful, like and subscribe for more coding projects. And remember, AI won't replace doctors, but it can make their diagnosis faster and smarter.